Hello, good morning students. Myself Shweta Gedam, working as an assistant professor at Sandeep Institute of Pharmaceutical Sciences, Nasik. Today we will discuss preformulation topic. The first question arises: what is preformulation? Preformulation is a phase of a research and development process where a preformulation scientist characterizes physical, chemical, and mechanical properties of a drug. Why is preformulation important? Preformulation work is the foundation of developing formulation. Good preformulation will inevitably lead to simple, elegant formulation and successful commercial product. We can define preformulation as an investigation of physical, chemical, and mechanical properties of a drug substance alone and then combined with excipients. Now, what is objective behind performing this preformulation study? The overall objective of preformulation testing is to generate information useful to the formulator in developing safe, stable, and therapeutically effective dosage form which can be mass produced. Now, pause your video and think, which are different steps of preformulation study? Okay, let's see and click the answer. Preformulation study parameter, we can study these in two steps. One is physical parameter study, another one is chemical parameter study. Now, different physical parameter study. Physical parameter study involve organic properties. Now, why it is important to study organic properties? Because a typical preformulation program should begin with the description of a drug substance. As most of the drugs are supplied from different sources, their color, odor, taste are to be established well in advance to avoid any variation in quality, and it is important to establish a standard terminologies to describe these properties in order to avoid confusion among scientists using different terminology to describe the same property. Another parameter is particle size. Why particle size study is important? The size of particle can affect processability and the dissolution rate of the drug. For high potency of drug, it can be advantageous to have small particle size to maximize the number of particles in order to allow adequate mixing and dose uniformity. Next parameter is particle shape. Whether particle shape is spherical or irregular affects flow property and its drug content and ultimately its surface area and dissolution. Because in case of spherical particles flow properly so that particle size decrease and spherical particles give us more surface area as compared to irregular surface area. Next parameter is surface area. One of the reasons for controlling particle size is that changes will alter the available surface area and subsequently affect dissolution and potentially bioavailability. For dissolution study, for dissolution purpose, we want more surface area of particles. Next parameter is physical form. In physical form, whether drug particles are crystalline in nature or amorphous in nature. As amorphous form of the drug give good dissolution and solubility as compared to crystalline form, always we prefer amorphous format of a drug. Next parameter is partition coefficient. What is partition coefficient? We can define it as the ratio of unionized drug distributed between the organic and aqueous phase at equilibrium. Next parameter is hygroscopicity. Hygroscopicity study is important because some drugs, when kept in open containers, have tendency to absorb moisture from atmosphere and get converted in liquid form. Hygroscopicity is dependent on humidity, temperature, surface area and exposure time of the compound. Next parameter is wettability. Wetting in general may be conceived of as a process by which the liquid establishes contact with solid surface to form liquid-solid interface. The liquid can spread all over, displacing absorbed gases and completely wetting the solid. The wetting tendency of a drug is important for its dissolution. Next parameter is flow property. Powder flow properties. Powder which are used in formulation for any pharmaceutical purpose may be classified as free-flowing powder and non-free-flowing powder or cohesive or sticky powder. So, flow property of a powder are significantly affected by the changes in particle size, shape, porosity, density, electrostatic charges present on particle, surface texture and absorb moisture. It is important in tablet formulation. Capsule filling, powder filling, container granulation, punching of a tablet, etc. and can be determined by angle of repose and Housman's ratio, compressibility. Last parameter of our physical parameter study is solubility study. In solubility analysis include pH solubility profile study, determination of pK, temperature dependency, solubility mechanism and rate of dissolution. Factors which affect solubility and dissolution include pH, temperature, ionic strength and proper concentration. Now another parameter are chemical parameter. In chemical parameter, first parameter is salt formation. The particular salt form that is selected will alter the physical and chemical properties of a drug. For example, the pK of the drug and its interaction with the solvent will change. Salt form a drug alters or influences the drug solubility, rate of dissolution and absorption, and it can be explained by considering the pH of the diffusion layer. In case of a salt of weak acid, at any given pH of the bulk of the solution, the pH of the diffusion layer of the salt form a weak acid will be higher than the observable in the free acid form of a drug. So, we form a salt of a weak acid with a strong base and weak base with a strong acid. Another parameter is hydrolytic degradation. Hydrolytic degradation is the degradation of a drug in presence of water. A number of chemical structures such as amides, esters, lactones, sugar are known to be susceptible to hydrolytic degradation. Next parameter is oxidation. Oxidation, a chemist concept of oxidation is the loss of electron or addition of the oxygen to a compound, right? So, certain chemical entities are prone to oxidation. Example, ascorbic acid, morphines, epinephrine, Most of the degradation of compound are first or second order reaction. The characteristic of oxidation reaction is that they often result in colored product. Thus, even in situations where the degradation product is not toxic, the product may be spoiled by the color change. And that's why oxidation study is very, very important. Next parameter is pK determination. Determination of the dissociation constant. Right? pK determination, it is nothing but the dissociation constant. For a drug capable of ionization within a pH range of 1 to 10 is important because solubility and absorption can be changed with changing pH. For determination of the dissociation coefficient, constant, Henderson-Hasselbalch equation is used. For acid, pH is equals to pK plus log ionized form of a drug to that of unionized form. For bases, pH is equals to pK plus log unionized form of a drug to that of ionized form. Next parameter is permanent effect. As the solubility of electrolyte has been shown to depend upon their degree of ionization, factors that reduce ionization will reduce the solubility. Thus, weak electrolytes in presence of the common ions such as a hydrochloride salt of a weak acid in the stomach will show significantly lower solubility than it at an equivalent pH with the common ion accept. Next parameter is dissolution. Dissolution study is very important in solid dosage form. Experimental data are obtained by in vitro study are utilized for the determination of the bioavailability. So, dissolution rate of a compound can be determined using Lewis and Rutney equation. That equation is dC by dt is equals to dA upon HV CS minus C, where dC by dt is dissolution rate, D is diffusion coefficient, H is thickness of the diffusion layer, V is volume, and CS is concentration of saturated solution in dissolution medium, T is time, A is surface area, and so C is concentration of a drug in bulk of the solution. Last parameter of chemical parameter study is stability analysis. As with many aspects of preformulation, stability studies should be considered in two ways. Firstly, it is necessary to develop a profile for the drug substance, and secondly, at an early stage, it is necessary to consider possible interaction between the drug and excipient that are candidate for inclusion in the desired formulation. In this respect, the aim of the preformulation testing are to identify routes of degradation of the active substances, indicate the type of excipients that would improve stability, and to screen other excipients that will be necessary for product manufacture, and thereby solid state stability, solution stability, and solubility in presence of liquid. Study is very important. Thank you.